Good morning, ma'am. My name is P. Lakshman from Triple Apartment. My roll number is 209558012. Subject is electrical hybrid vehicles. Today topic is about optimal driving control of hybrid electric vehicles during stationary condition. It is done. It is the known that the Proteman-Hagen maximum principle suggests that completing a system within the n differential equations first statement and the statement variables which call phasor coordinates and the system of the n differential equations of the cogent cognitive variables. In case of a linear description of the controlled object, the characteristics equation of the combined system of differential equations has n roots in the left of plane of the complex plane and the n roots of the right of plane. The combined system of the two n equations turn on out of the unstable. During the acceleration, free moment of the velocity v is negative and the absolute value described up to 0. Free component corresponding it the roots of the characteristics equation lying in the left of plane. It is a stable root. At the stationary moments, the speed is constant and the equal to the forced component. During the braking, the speed decreases to 0 and the free component is negative and increasing up to the equation lying in the right of plane. It's the unstable roots. The statement of the optimal control, the uh, problem considered the problem to find out the optimal station is electric drive within the initial ob- object and the electric motor. The moment of the control object is described by the equation which is this dx by dt is equal to x2 where dx2 by dt is equals to cu minus me x2 by j, where x1 is the alpha is the object rotation angle and x2 is the omega angular speed and c is the coefficient of the electromagnetic moment and the emf of the rotation. U is the control function which equals to the electric motor control of the inertia of the electric drive moving parts. The static torque is determined by the equation is m is equals to k naught plus k1 into x2 by x2 plus x2 into k2 into x2 square. The first term is corresponding to the active torque due to the including roads and the moment of friction. The second term is viscous friction moment of the moment, and third term is corresponding to fan or aerodynamic moment. The equality of control is determined by the functionality v is equals to integration of 0 to 1 on the ru square plus x qx2 delta 2, and the solving condition maximum problem is t of x, f is equals to alpha f by x2, and this is the equation by the Newton's method using the irritative irritate, irritative equation. X2 comma k1 plus is equals to x2 comma k minus dv by dx dx2 d square v by dx square whole square. And after determining the parameters corresponding to the steady state moment mode of the operation of the electric drive, it is advisable to solve the problem optimal control of the electric vehicles by the Pantotry again maximum principle to verify the stationary of the optimal moment. To do this, the equations and the constant variables as well as maximum conditions of the alley tolerance or road h is equals to minus ru square minus x2 cx2 u minus q plus Simon x2 plus Simon x2 by j, and the last 12th equation is dou h by dou u is equals to minus ru minus 2ru minus cx2 plus omega sigma c by j is equals to 0. And solution optimal control problem as an initial condition of the conjugate conjugate variables accepting the values of sigma 1 and sigma 2 objected by the equalities. Moreover, the h's must be identical equal to the 0, which corresponding to optimal travel time. The parameters of electric drive had been followed are R is equals to 3 ohms and C is equals to 2 volts per second, and the joules is equals to 0.5 kg per meter square, and K naught is equals to 0 2 or 1, and K1 is equals to 0.004, and K2 is equals to 0.0008. Alpha F is equals to 150 radians, and integration step H is equals to 0.00C. This time scale of the is equals to 150 rotation of the angle, which is used to determine the stationary motion. It could be seen that with an increase in the q, the angular speed x2 and the cognitive variable which has increased to and travel of the tf decreases. The h values, the h in all cases is equal to the 0, which indicate that optimality of the motion is time in time. And these two are the equations which is obtained to the motion time and the indicating function v 0.8, and it been seen increasing q motion if the ft decreases and all the other values are increased. And this is the two graphs which is the function of angle and the speed of the on time, and the next one is the function of travel with the time, speed and variables of the machine, and the optimal control of the electric drive with the constant speed. Considering the optimal problem hybrid electric vehicle with constant speed, the motion of the hybrid electric vehicle is described by the equation 3. The equation 3 describes that each and every value will be equal to the x1 and x2, which is q1 and q2, which is the total moment of inertia decrease to the shaft to the diesel engine, and the mc1 decrease the static moment of the resistance to determine the equation q, and whereas x1 x2 are the phase coordinates, and the values q1 q2 are the control function. The time interval at t0 and tf is determined. The initial and final condition is given by x1 t0 is equals to x1 naught d0. The determine values of diesel fuel and the electric vehicles, which is it solved problems fuel and the consumption of the engine determining by the corresponding, and the power consumed by the electric drive described by this equation. And whereas the torque is m3 is equal to 0.2 coefficient for the diesel engine model, and the maximum power pm is equals to 75 kilowatts. The angular speed of the maximum power angular omega p is equals to 150 second per minute. The maximum torque is 500 newtons on the scale observed by the electric vehicles, which is used to determine these values. The degree of diesel engine used to q1 had no value of from 0 to 1. The step of is changing for the calculation of the first and second derivatives of 0.01, and figure shows that. And the torque equals torque of the diesel engine and the electric motor m1 and m2 equality indicates v, and the time of movement t, f tf from the cost q2 given. uh, the x-axis given the cost and y-axis given the uh, time variation between the two. We have identified in the total cost of the speed of the vehicles, and it can be seen by the increase in the cost q and optimal speed increases. The travel time decreases in case of the moment of resistance increases mc due to the viscous friction and the aerodynamic drag. The result in the electric motors also increases, v also increases. The independence of the optimal values mu x2 tf and u1 and m1 m2 v from the value q with the other parameters value. There are a exchange of the moment between the diesel engine and electric motor while obtained. Only parameter that different from the previous task that gain given coefficient determining the static moment of resistance K0 and K1 and K2. The conclusion: in case of hybrid electric vehicles, control is seriously problem in the choosing of gear ratio of gearbox or hydromechanical transmission and the total is distribution between the internal combustion engine and the electric motor, taking into account of the road profile and the limited energy stored in the capacitive storage of battery. The choosing of rotation which is used for the hybrid power plant depends on the place and operating conditions. The problem of choosing the type of motor and the should be solved in the conjunction of the with the problems of controlling internal combustion engine in the vehicles as the whole, taking into account main technical requirements as well as the requirement of economics and thank you, sir.